There are these animals that came from off-world. These are parias. NASA, well known for its basic divulgences, has indeed uncovered that this new planet isn't just charming, taking into account the truth of its size and region, but also considering the reality that it shows lights that have each one of the stores of being fake. Are we, for all intents and purposes, uncovering insider genuine realities that could change our perspective on the universe? Could this discovery sooner or later mean there is life on different planets? Go with us as we see NASA's charming revelations and uncover the truth with respect to these shocking lights. In 2007, NASA launched the Dawn spacecraft with a mission to examine the most charming objects in our nearby planetary system. Dawn was marvelously equipped with 3 ion engines, allowing it to embrace an extraordinary journey. Dawn's excursion started with a 14-month assessment of Vesta, the second largest asteroid in the belt. During this time, Dawn sent back detailed pictures and data revealing Vesta's puzzling surface and different land accounts. Following the completion of its primary mission at Vesta, Dawn set out on the second and perhaps most captivating part of its journey, a close evaluation of the dwarf planet Ceres. Considering its ion engines, Dawn had the choice to leave Vesta's orbit and set out on a mission to reach Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines, given a consistent gentle push, enabled Dawn to travel tremendous distances efficiently and enter a consistent orbit around Ceres. First tracked down in 1801 by Italian astronomer J.P.I. Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the tiniest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most significant body in the asteroid belt and one of the most fascinating due to its interesting characteristics. As Dawn advanced toward Ceres, scientists eagerly anticipated the first detailed photographs of this bizarre world. They saw bright spots scattered across its surface, most strikingly in a huge crater now known as the crater's crater. These bright spots ignited brief interest and hypotheses among scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Researchers had scant knowledge of this dwarf planet, and the opportunity of finally getting a close-up view was exciting. What mysteries would Ceres reveal? What new revelations awaited the mission? Dawn promised to improve our understanding of the nearby planetary system's development and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquids instead of molten rock. But what exactly are these puzzling lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt due to its size, mass, structure, and potential for water and ice. Unlike most rocky asteroids, Ceres has a structure more like a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This marked a critical milestone in the mission as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew closer, the images of Ceres became progressively detailed, offering brief glimpses of a world previously shrouded in mystery. The initial images revealed a surface dotted with craters, characteristic of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space fans alike. Among these features were strange bright spots that stood out starkly against the darker, rough terrain. As the photos continued to improve in resolution, scientists buzzed with speculation about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something far more unique? Theories ranged from mineral deposits to possible signs of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single entity, but rather perhaps a mix of several distinct regions. This discovery only deepened the mystery. The hypothesis that these were deposits of salts left behind by sublimating water gained momentum. This would suggest that Ceres had or still has some form of geological activity capable of moving water or briny liquids to the surface, where they rapidly evaporate, leaving behind bright reflective deposits. These revelations challenged existing ideas about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres particularly significant compared to other planets? Ceres is an intriguing world, often described as a cold planet with a harsh yet fragile surface. Unlike most asteroids in the belt, which are made primarily of rock and metals, Ceres stands out due to its unique composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, which gives it a significantly less dense structure compared to its neighbors. This composition suggests that Ceres contains a substantial amount of water. The surface layer is rough yet permeable, with ice and other volatiles trapped inside. This cold characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that may have involved a mixture of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up around half of Ceres' total volume. This mantle, possibly a mixture of rock and salty water, surrounds a core that may be made of denser material, possibly silicates. The presence of so much water ice suggests that Ceres may have once held liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its potential for geological activity and the role of water in its development. However, that isn't all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder part of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this fascinating dwarf planet, but also provide significant clues about the processes that govern the evolution of icy bodies throughout the solar system. Cryovolcanism is a unique and somewhat colorful geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike conventional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles like water, ammonia, or methane. These substances can exist as liquids or gases in the frigid conditions where cryovolcanoes are found. On Ceres, cryovolcanoes work by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to gas, leaving behind bright reflective salt deposits. These salt deposits form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater known as Crater's Crater, specifically in an area referred to as Spot 5. This region has drawn significant attention due to its high reflectivity and unusual fogs observed by the Dawn spacecraft. These fogs are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. Furthermore, Ceres has several other bright spots, each with its own unique characteristics. These spots are not confined to one region but are spread across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the unique nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The surface of Ceres is marked by numerous craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface that has been subjected to multiple impacts over billions of years. Others are better preserved, with sharp edges and deep bowls, suggesting more recent impacts. Curiously, the number of craters on Ceres is fewer than initially expected, which could indicate that geological processes might be replenishing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy surface allows for a form of cryovolcanic resurfacing, where subsurface materials occasionally well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world, but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, ridges, and faults on its surface. These features indicate that Ceres' exterior has experienced significant stress and stretching. Some of the fractures appear relatively young, perhaps only a few 100 million years old, suggesting that the crust is still somewhat dynamic. The ridges and faults on Ceres likely formed as the surface was stretched and pulled apart, while mountain ranges and compressional ridges indicate areas where the surface was pushed together. These contrasting features offer a glimpse into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal stress or upwelling of materials, possibly related to cryovolcanism. This feature, along with the extensive network of fractures and ridges, points to a dynamic and evolving surface. Dawn's mission has also uncovered fascinating surface compositions. Beyond the bright spots and reflective salts, NASA's data has revealed a range of surface materials that are crucial for understanding Ceres' geological history. For instance, specific regions on Ceres show a dark, fine-grained material that stands in stark contrast to the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, adding another layer of complexity to Ceres' composition and suggesting a potential for prebiotic chemistry. The connection between these materials and the icy surface could play a role in the chemical processes taking place on Ceres. Moreover, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found in carbon-rich mixtures. These discoveries are especially exciting because they suggest that Ceres may have conditions suitable for the development of more complex organic molecules. The presence of these compounds opens up possibilities for life, or at least the building blocks for life on this dwarf planet. Another surprising feature is the large number of bizarre, dome-shaped structures on Ceres. These domes, some reaching heights of up to 6 kilometers, are believed to be the result of subsurface processes pushing material through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or internal pressure forcing materials upwards. Understanding these formations is crucial for unraveling Ceres' geological history and its internal structure. In addition, the gravity data collected by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of different layers within the dwarf planet, suggesting that Ceres' interior may have complex structures, including a possible subsurface ocean or briny pockets. These discoveries are vital for understanding Ceres' thermal history and its potential to support conditions conducive to life. Overall, the Dawn mission has not only expanded our knowledge of Ceres, but has also changed how we think about small celestial bodies in the solar system. As more data is analyzed, scientists hope to unravel the secrets of this captivating world and its potential to offer insights into the broader processes that govern planetary evolution and development. The discoveries made by the Dawn mission have redefined our understanding of small celestial bodies in our solar system, particularly with respect to the presence of water, organic compounds, and active geological processes. These revelations suggest that Ceres is far more than just a small icy body, and its potential for hosting life, or at least the building blocks of life, has opened up new avenues for scientific exploration. The identification of organic compounds and ammonia clays indicates that Ceres may have once had the right conditions for life to emerge, or at least the necessary ingredients for life to form. The discovery of Ceres' complex surface features, from its bright spots to its cratered landscape, highlights the dynamic nature of this dwarf planet. The possibility of ongoing cryovolcanic activity, where water and salts are expelled from the subsurface, challenges the previous assumption that Ceres was a geologically dead world. Scientists are now reconsidering how planetary bodies in the asteroid belt could have developed, with Ceres offering new insights into the processes that shape these worlds. For example, the formation of dome-shaped structures on Ceres, along with the observation of fractures and ridges, further supports the idea that the dwarf planet has undergone significant internal and external stress, possibly linked to cryovolcanism or other geological activities. The presence of a possible subsurface ocean or briny pockets within Ceres adds another layer of intrigue. This discovery suggests that beneath its cold, icy exterior, Ceres may harbor the kind of liquid water that is crucial for life as we know it. A subsurface ocean could offer a stable environment for microbial life, if conditions are right. Scientists continue to study the gravity data and other findings from Dawn to understand the full extent of Ceres' internal structure and its potential to support life. Moreover, Ceres' composition, which includes hydrated minerals and carbonates, provides clues about its past. It's likely that the dwarf planet's surface was shaped by both icy and rocky materials, perhaps as a result of collisions with other bodies in the early solar system. This mixture could explain the planet's porous, low-density structure, which is more similar to comets than typical asteroids. The ongoing analysis of Ceres' surface features and composition promises to provide valuable information about the history of our solar system and the conditions that may have allowed life to form on Earth. As more discoveries unfold, Ceres will remain a key focus in the search for extraterrestrial life and the study of planetary evolution.